Guys, the diagram shows a complex number Zn where 0 is less than n is less than 7. Okay? Now it shows a diagram of these complex numbers. The transformation Zn onto Zn plus 1 is a positive rotation of pi over 4, pi over 4 being 45 degrees. Okay? So, what we're going to have here, guys, is what this means is the transformation of Z1 to Z2 or Z2 to Z3. Basically, any value of n you want can fit in there. So, for example, Z0 to Z1 is 45 degrees, this is 45 degrees, 45 degrees. Just basically 8 sections, 1, 2, 3, 4, 5, 6, 7, 8, 45 degrees all the way around. Now, what's going to ask is write down the argument of, for example, Z3. Well, the argument of Z3 is going to be 135 degrees because it's 3 times 45, so it's going to be 135 degrees. The argument of Z7 is located here, 45 degrees short of 316, so it's going to be 315 degrees. Okay? Now, what it says is the modulus of Z0 equals 1. This means the whole thing has a radius of 1 because it's a circle. It goes expressed in the form a plus bi Z2, Z4, Z1, Z5. Well, what we can start off with is that we're always going to use polar form, or cos theta plus I sine theta. And for part 1 of this question, Z2 is going to be 90 degrees, so theta equals 90 degrees for the first part 1, or part A, excuse me. So this is part 2A, and it's going to be 90 degrees, so it's going to be 1 cos 90 plus I sine 90, and what we're going to get here is 0 plus I. Part B is going to be Z4, and Z4, as we can see, has a 180 degree rotation, so theta equals 180 for Z4, so it's going to be 1 cos 180 plus I sine 180. Okay? Minus 1 plus 0 I. C. Z2. Okay, so we're talking about Z2. So Z2 is, as you can see, 45 plus 45 is 90 degrees. Okay, so Z2 equals 90 degrees, so it's going to be 1 cos 90 plus I sine 90. And what we're going to get here is, wait a second. Z2 is 90 degrees, so I've already done 90. Oh, it's Z1, sorry guys, Z1, I'm looking at the wrong one. Z1, so Z1 is 45 degrees, excuse me. So, 45, and what we get here is 1 over root 2 plus 1 over root 2i when you multiply it out. And finally D is Z3, and Z3, as we all know, is 135 degrees for Z3, so it's going to be 1 cos 135 plus I sine 135, and what we get this time around is going to be minus 1 over root 2i plus 1 over root 2i. Okay, now verify that the argument of Z1 plus Z5 equals the argument of Z1 multiplied by Z5. Okay, well, what we can say here is that the argument of Z5, did it again. Sorry lads, the last one I was meant to find out was Z5, which is this one here. And Z5 is 225, so it's 1 cos 225 plus I sine 225, and what we get here is going to be so let's double check on this. It's definitely Z5, and Z5 is 225 degrees. So just check it out here. Cos 225 is negative 1 over root 2. Same thing as 1 over root 2, guys. and then it's a negative 1 over root 2, and then the other one is the positive 1 over root 2. So we try sine 225. You get here's another negative 1. Now, what's asking for next is the argument of Z1 by Z2 the same as the argument as verify it, okay? So the argument of Z1 is the angle, which is 45 degrees. The argument of Z2 is 225 degrees. So we're looking at an argument of 200. We need to make sure that Z1 by Z5 is 270 degrees. So what we're going to do is we're going to get Z1 multiplied by Z5. So the answer to Z1 is this one here, and this is Z5 here. So what we can use as the rule is when you multiply two complex numbers by each other, you add their angles together. That's what you do. So R1 equals 1, R2 equals 1, A equals 45, B equals 225. So what we're going to get when we do this is 1 times 1, which is 1. And then it's going to be cos, add the angles together, which is going to be 270 plus I sine 270. So we verified that that there is in fact 270 degrees. Expressed in polar form, Z1 and Z1 is already expressed in polar form, but we'll express it in polar form again anyway. So this time around, we're asked to express Z0. Well, Z0 has no angle, so it's going to be cos 0 plus I sine 0. That's Z0. Z1 has 45 degrees in it, so cos 45 plus I sine 45. Next one, Z2, which is going to be cos 90 plus I sine 90. And then finally Z3, which is cos 135 plus I sine 135. Okay, so that's all of these ones done. Express Zn in polar form and hence verify your answers to part 2. Well, Zn will therefore, it's basically 45 multiplied by the n number. Okay, so the first one's 0, the second one's 45 times 1 is 45, 45 times 2 is 90, and 45 times 3 is 135. So it's going to be cos 45n plus I sine 45n. And all we have to do is replace in the numbers, and we can see that it's already written in polar form in part 2. And when you put these numbers into the calculator, you get the same numbers out, so it's already verified. Okay, evaluate. What it wants us to do next is it wants us to evaluate the sum of the 7 terms. It wants us to evaluate what Z0, Z1, plus Z2, plus Z3, plus Z4, plus Z5, plus Z6, plus Z7 is. Okay? Now, if we were to make a big long list of all of them using the Zn formula, what we'd also get is Z4, which is going to be cos 180 plus I sine 180, Z5, which is going to be cos 225 plus I sine 225, Z6, which is going to be cos 270 plus I sine 270, Z7, which is going to be cos 315 plus I sine 315, and then Z8, which is going to be cos 360 plus I, but we don't have to go as far as Z8 because Z8 doesn't exist because it stops at Z7. You can see that up here, that stops at Z7. Okay, now find out what they are all added together. So what I'm going to do is I'm just going to go to my calculator, and what we're going to do is we're going to add all the costs together. So we're going to get cos 0. We're just going to add all the real parts together. Cos 45 plus cos 90 plus cos 135 plus cos 180 plus cos 220 plus cos 270 plus cos 315. What we get here is 0. So when you add them all up together, you're going to get equals 0, and then we're going to do the same with the sign. So let's just do this from the scratch. Sine, probably just a lot easier just to clear it up actually. Alright, so sine 0 plus sine 45. I'm fully expecting this to be 0 as well. Sine 45 plus sine 90 plus sine 135 plus sine 180 plus sine 225 plus sine 270, and then finally plus sine 315. What we get here is 0. So 0 plus 0i. Okay. If set 7 equals set n, where n is element n and n isn't 7, write down the minimum value of n. Justify your answer. Okay, well, set 7 is cos 315 plus I sine 315. Okay, so what we have here, guys, is it has to be an angle that's equivalent to 315 and 315. If we add on 360, what we're going to get is cos 675 plus I sine 675. And please remember, this is the same general form as cos 45n plus I sine 45n. Divide 45 into 675, and we can see what value this repeats at. So 675 divided by 45, what we're going to get is 15. N equals 15. So n equals 7 is the same thing as n equals 15. This is because 8 rotations, there's 8 different complex numbers per rotation. Z8 is the same thing as Z0, and Z1 is the same thing as Z9, and Z2 is the same thing as Z10. They all land on the same spots after the first rotation. So basically, if you look at it like this, guys, look at this red mark point here. We go Z1, Z2, Z3, Z4, Z5, Z6, Z8, Z9, Z10, Z11, Z12, Z13, Z14, Z15. Z15 is the same thing as Z7. Okay.